just give you to a concept of how do we derive those like B, E, B, T, D, V, those B stuff, alright, the standard general equation for your stiffness matrix, alright. So in this case, we'll use the virtual displacement we have done earlier, alright, to actually prove to you for the bar, alright, in a more quicker way, alright. The quicker way is that, okay, now we know that this is stress. Stress, you know that is in terms of Young modulus times your strain. Alright, so I can rewrite your stress as this one, okay? And therefore, the rest of it, I'll just simply write it down to 0. Alright, next, alright, I know that my strain is just a U is equals to N1U1 plus N2U2. This is from the past videos, if you still remember. It's just a shift function in terms of a U1 and a shift function in terms of U2. That's all. We can rewrite this as a NTU, alright, UI, some vectors, okay, and therefore U is equals to all this stuff over here. And how does this U apply? Alright, we know that the strain is equals to some du over dx. Your dx is some of original length of your beam, right? So in other words, your bar, not beam, this is du, and this is your original length dx, if you get what I mean. So the strain is simply this manner. So I can simply write my strain in terms of du over dx. Same thing for my virtual, I'll just write as like this, okay? And then minus FUV equals to 0, okay? Now I can simply sub in my u is equals to all this stuff, alright? So what we have is, okay, so just simply rewriting u as your this thing over here, rewriting u virtual as this thing over here, okay? And you may be tempting to also change your view v over here to this one. Don't do that, okay? Please don't do that. Alright, just leave it like this here. Overdo, alright? And then your uv over here, your virtual u, can be right in terms of nt multiplied by your uv, alright, your matrix of vectors of virtual u. Alright, so I hope this is pretty clear to you. And we know that dn over dx is equals to your strain displacement system. So therefore we get to see that this whole thing over here is actually your dn over dx. So you can simply write this thing over here as your b, alright, or this thing over here is also your b because it's dn over dx, right? We have proved to you that dn over dx is equals to your strain displacement b. Alright, so I just simply sub it in only. But it's in terms of transpose because over here is the transpose. Alright, while the ui over here I'll just simply write as ui. Alright, ui for virtual is just simply identity matrix 1 1 0 0 0. Okay, so I'll just simply write it as identity matrix. Maybe let me see. I'll just write as 1, okay? So just take note that this virtual u, alright, virtual u is just simply extension of the BT only, that's all. I don't know where it comes from, but it's just the meaning. Alright, the virtual u over here is just times 1 also. Okay, maybe I should write in blue for the forces. So I have force, and then this is just times 1. Okay, minus these things, alright, is equals to 0. Okay, so I hope that this is kind of clear to you. And we may forget something, is that my E over here I didn't actually bring it down. This strain I bring it down, this strain I bring it down, but I actually forget to bring my E. Alright, so my E is actually, I have factorized it outside, but I didn't seed it. So let me just add it in. Alright, so over here. Okay, so therefore this is some form of what you do. And then I'll just simply bring this thing over to the other side. So I have f times 1 is simply f, because it's just an identity matrix only. So therefore I'll have f is equals to the integration, should be more exact, is v over dv. Alright, because if you were to just take a look, it's in terms of this dv over here. So you're integrating in terms of the volume. Alright, I would have b u, alright, and then e bt. Alright, instead of u over here, I just actually should have bring it to at the back. Alright, so this ui over here, and then e bt, alright, dv and then multiply with ui. Okay, so this is v and then the v. Okay, so therefore this whole thing over here is your stiffness matrix K. Alright, BE, BT, dV. So therefore this is just some form of derivations for your bar. At least you get to see how the virtual displacement actually helps you to do this. Alright, and therefore this is it. Next video we'll do about the beam. Alright, and I'll see you there then.